All right, so today we're talking about integrated tools in SolidWorks. And that really can mean a lot of different things. So I picked a few of my favorites just off of the top of the list. Now, this webcast is going on right now, and we are recording what we're doing right now. So I just wanted to take 1 second and just say hey to everybody out there, just so you know you're talking to a live person. My name's Darin, and I've been with the company for quite a while. And getting into my PowerPoint here, 20 years, 21 years now with the company is you see the product change a lot. And it goes from just a little tool to create geometry to really the center of your ecosystem when it comes to where we use SolidWorks. So I've got to watch the product grow quite amazingly over the last 2 decades. And this is one of those examples of things that we do where we're adding content to the product constantly. So let me just get out of my webcam here for a second and we'll go through the next few slides real quickly. So I've been here a long time and there's a few things on my stat sheet here. I'm really just most proud of where I've come with my marriage, personal life, and my kids. And when I'm dealing with things at home, I really use SolidWorks more than I use it anywhere else. And if you've seen any of my presentations before, I show a lot of this stuff because frankly, I'm an engineer when I'm at work, but I'm also an engineer when I'm simply at my home. And I use SolidWorks for a lot of things. So this design here is a treehouse, and I used SolidWorks weldment technology. And what this allows me to do is use the same type of framework that we would use to create a structural steel shape, but using just a little bit of a different technique, we can leverage things like wood profiles, and that'll give us the same type of cut list. And I use it for form, fit, and function. Whenever I can visualize something, I just simply build it up in SolidWorks quickly and go from there. Now, what else I do with the software is really sort of get my plan of attack. And as a bathroom project here, it was more about fitting things in. And when you have to run infrastructure, you want to know that there's room for things like electrical, not just the connectors or wires, but also the things that connect to those. And you find those out pretty quickly. And then I spend a lot of time just building parts and inventing things and really just solving problems. But it allows me to use the software, and I'm exercising my SolidWorks skills as I go. So I encourage you to get a hold of your software at home using online licensing, and that will allow you to actually get some stick time and better capabilities. When we're talking about integrated tools, there's a lot of places we can go, and what I've chosen today is focus on 4 integrated tools, and they're peppered throughout various areas of SolidWorks. And this happens because of something we call the waterfall effect. So if you've been with us for more than a few years, you've noticed how enhancements are added to the software in a very rapid and constant pace, and that's a tremendous growth thing that we do. So we're trying to fill all of our enhancement requests as quick as possible. But you end up with products that have different features and functionality simply because of the different layers that we have within the tool. Now, SolidWorks Standard has every CAD function, but when you start to get up to professional and premium, you start to get to productivity tools. Today we're going to talk about FeatureWorks as well as some library capabilities, some PDM capabilities, and so on. But back in 2014, the picture was much different. Here we have what SolidWorks 2014's package bundles looked like, where PDM, Professional now is what it's called, was a separate purchase, as well as sustainability, aside from a couple of our wizard type tools. In 2015, though, something happened. We started to drop some of the functionalities from 2014 down into 2015. And I've got to back up my slides here for a second and see if I can get these things to actually transition with the animations. Because essentially what you get as a result of this is products dropping from version to version and giving lower versions accessibility. So here we drop CircuitWorks and sustainability down into the lower bundles. 2016 brought a bigger change, however, and we actually dropped a few things right down into standard. So this is where utilities sits, this is where FeatureWorks sits, and then a feature we added to our model-based definition tool called Model Breakview is now a standard feature as well. And then those of you on Professional gained a whole bunch of other functionality, including a little brother to PDM Professional called PDM Standard. It's based on a database. You're going to see a lot about that today, as well as things like Scan to 3D, which are now lower level products. And then simply on the higher level, we keep some nichier tools like assembly costing and flattened surface. And that's much what the picture looks like today with SolidWorks 2018. So I've picked these 4 topics just to briefly go through to give you some recognition that they're there, because we live by the mantra, if you don't know what you don't know. But we also need to flush these out just a little bit to give you enough knowledge to maybe explore these. So I'm going to start with Task Scheduler. And that's really an automation tool. We'll get into that. It's a set it and forget it type of feature, or something that you can used to have your computer processing something at off hours, for example. And then libraries and resources. These are the types of places where you can gain a lot of productivity because you don't have to remodel things, especially purchased goods, if you simply know where to find them. Now, things that you do on your own, you can produce your own design library, but there are several resources out there that are available free of charge to download data. FeatureWorks is a cool tool for dealing with imported data. And it's based on being able to edit those files. So a featureless part that you import, you'd want to be able to put parameters to it and make changes. And it's one of those things where you can pick and choose what you actually edit on a part, but it gives you the ability to control your own destiny for files that you didn't even model from scratch in SolidWorks. And then we're going to finish up with PDM Standard. Now, PDM Standard is simply data management. It's just a different layer or level than what we do with PDM Professional. Still controlled by a database. Its basic premise is revision control, check-in, check-out, permissions, and the revision management of those files. What it's also good for is stability and performance because of the mechanism we use to bring those files locally. So what we're going to do is talk about each of these, and currently they fit into these bundles. So every version of SolidWorks has libraries and resources and FeatureWorks. You have to get up to Pro or Premium to use most of the features in Task Scheduler. There is one feature that works in SolidWorks Standard. And then with PDM, that's also included with SolidWorks Professional and SolidWorks Premium. So let's get started. With our Task Scheduler, what we're talking about is simply automation. It requires a professional or premium license. However, this feature called Convert Files is available in SolidWorks Standard. And that's basically the file conversion wizard. It'll open them up and save them in the newest version in an automated manner if your company goes through that particular process when they upgrade major releases of SolidWorks to make sure that those files are upgraded and saved into the main release. Now, this is located in your this part that's in standard. This is located in your programs group. So when we're dealing with these types of features, they're all buried in your start menu. Some of them get their own tools up top, sometimes on your desktop icons or on your taskbar. But if you simply hit your Windows button, which I'm going to do here to show you where to go, you can get into the Windows Start menu and then simply scroll down to SolidWorks. Now, I prefer to use the search, but I want to dive down deep to where these are. You have your SolidWorks install areas, and I have 3 major releases currently on my machine. I'm going to go under SolidWorks Tools 2018, and that's where you're going to see a few of these features. So you get Toolbox, you get the Treehouse, up here you get Performance Monitor, Property Tab Builder, and so on. Now, the Task Scheduler falls right down in this area. And when you open it up, it's a lot like the old defragment tools of the past, where you would choose a task and then set it for a time to execute. Now, when you're doing these types of things, you have a lot of choices. Now, these could be used for cool things like automated printing of files. So if it's something you want to do on off hours when nobody's there, we can simply say, I want to print files. You choose either individual files or a complete folder, if that happens to be the case. And when you select that folder, you can even choose the types of files in that folder that actually get printed. So if it's just drawing packages, simply boil it down to that. Choose a time, choose a execute time and date, and then where the files are going to go. You can actually kick them off to a separate folder and simply browse to that location, or you can just save them in the original folder. And this is really more for if you're saving files out. This happens to be a print, so it's not quite going to use this particular feature. But just simply say finish to this, and it will schedule that feature, and it will run it at the prescribed time, which in our case, it's actually going to go ahead and kick off right now, which you can actually see it happening. So I'm going to stop this just to kill the process. But you saw how that actually executed right now. And it's opening up files and it's trying to run these operations. So we're going to go ahead and get rid of this one. Okay, log file could be deleted, and now my printer is kicking off. So that's what we're looking for. Very cool. Other things that are possible is automated import or export of files. Now, the file export is going to be relative to whatever file types SolidWorks can save. And it can even be things like JPEGs, image files. These are powerful because if you're in a data management environment, this is actually a neat way to be able to go ahead and grab a folder full of, say, drawings, for example, and then export those out as DXF or images for marketing or PDF files. So again, it's simply a choose the file type you're going to create. We're going to export files to PDF, and we would do the same type of operation where I would simply grab a top-level folder, tell it what types of files I would export as a PDF, and then set it where to go. Now, this is where the export folder location is critical because you are creating files in this circumstance. So again, a very cool item there. I'll set it for tomorrow, and when I say finish, And we'll go ahead and throw that in my queue as well. Okay, so other things that are great on this one, and then we'll move on, is automatic renderings and animations. This is great because it's going to go ahead and use things like photo view or your animation tools that you'd set up in your timeline, your motion studies, and it would kick off those animations to be scheduled for later. And anything like a render, which is a very compute-intense operation, it's more beneficial to do that, of course, when you're not sitting at your computer. Other things that get used quite often with this would be the automated creation of things like e-drawings, updating of a simulation, which is also a very compute-intense task, and then this thing here called updating associated files or file updates. Each one of those is just going to simply go ahead and update each of those tasks. Now, if you aren't sure with exactly what one of these things is, you can always go ahead and click on Help, and it's going to talk directly about it. So whether it's the associated files task or one that I really like here, which is actually this Upgrade Assistant, the Upgrade Assistant will actually open up your files in your current version and the new version and compare them side by side to find any differences. This is a really good tool for you to grab a random sample of your files, have it work on it itself, and then it will let you know if there's any geometric changes between your originally modeled version and the new version that you've loaded of SolidWorks to make sure that there's no discrepancies of the way that geometry gets created or the way the feature history gets rebuilt. So it's great for automating that process, and it does report back the differences with those files. So this is a great one for anybody that's just needs a little bit of confidence moving from one version to another, especially when it's a multi-version leap. So that's all we really wanted to cover on the Task Scheduler. Again, everything that's here is available with SolidWorks Professional and Premium. The Convert Files task, which would open up files in the newest version and simply rebuild and save them, converting them to the newest file type, is available all the way down to SolidWorks Standard. Just a quick slide here showing you the specific descriptions of each of those operations. The Upgrade Assistant's not listed on this one, but you did see in the property tool the verbose description of what it does. All right, let's hit libraries. Libraries are powerful. You just have to know where to find them. Now, every version of SolidWorks that you install comes with a default design library. The design library will be populated with a bunch of samples of everything that we can do. Now, we're talking about not the days of the old where it was just a block library, though the design library does have 2D blocks. You can store anything here. It can be an annotation, which would be a note, GD&T control frame, surface finish mark, something that's already produced and is simply drag and drop reusable. They could be assemblies. So if you're in the habit of downloading Destaco clamps and throwing them in a library, this is a great place to store them because all of your users look at the same folder locations. Easy deployment of standard components. These can also be PDM folders, so if you control them inside of a PDM vault, it's just the same thing. Sheet metal components, we're going to talk about these a little bit, these drag and droppable stamp features. I'll come back to those later. But then you can create your own features as well. And it's parts, assemblies, blocks, 2D things like notes and control frames, and then even sub-assemblies. So really anything that you reuse can be stored here. Now this one here is one that I've created myself. It's a type of connector used in an industry, and I've got a really interesting way of using each of these. We'll come back to this in 1 second. We'll talk about 3D Content Central. So let me just jump into SolidWorks for a moment and do a little live demonstration here. I just want to show very quickly how you can make something and put it in the library. So I'm just opening up a brand new part file. Now the example I want to show you here, I'm just briefly modeling from scratch, is just creating a rectangle. And this rectangle will not be part of the final feature. It's simply going to be the base that I use to create the new feature. We try to reference as few external features to make this as easy drag and droppable as possible, so self-contained. So I'm going to pick a single face, and that's going to be my only external feature. When I start a brand new sketch there, I'm just going to create something that theoretically here we would reuse. So I want to create a little bit of a slotted shape. And the slotted shape will have an extrude distance to it, and that'll just be an original distance. And then what I want to do on top of here is just drop a couple of holes on here. And again, without being very specific in the interest of time, let me just throw these 2 holes right there in the center. And I'm not going to worry too much about them other than just quickly making them equal. And I might as well just dimension this just for fun. Okay, so 1/4 inch. Now we're going to cut those very quickly through the entire part. And this will also be a behavior that is retained by these features in the final usage of it. And maybe pick this top face, and just for fun here, we'll throw a quick fillet on that. Okay, so what we have in our featured tree now are three features that I want to put in my library. You can find that on the right-hand side over here. Looks like a series of library books. I'll pin that in place, and that way it won't go away when I click in the graphics area. To make this feature in the library, what you do is use your control key to simply select the features in the feature tree, and then pick and drag them over into the libraries folder. This will initiate the creation of the final library feature. In fact, it will save those features as library items. It ignores the original base feature, as you'll see here, and then you can call it whatever you want. So I'm just going to call that boss for webinar. It is a library feature, not a part file. And then you can put a description on this. And sometimes I just use the descriptions that are the same, so we'll copy and paste it. And it's putting it in the folder that I dragged it in, excuse me. You can see right there, it dropped it into this folder, the Halmatro library, and that's exactly where it's loading it. So when I say OK to this, what it will do is it will create the boss for webinar. And if you notice it over in the featured tree, the three features that I actually selected prior to dragging them into the tree, into the folder, now have an L on them, which indicates that they're part of the library. So it's a really cool behavior. Now to use this, it's simply the process of using some of the drag and drop methodologies. So what I want to do is just open up a part real quick, and this particular part will go back into the folder I was just using. Now what we're going to do here is use this feature as a drag and droppable item. So all I have to do is grab it from the design library and drop it onto a face. And whatever flat face I drop it on, it's like the face that I sketched it on. Now I neglected to use dimensions to locate this, so there's not going to be any other external references for me to select for positioning, though you could edit the sketch at this point and simply put the dimensions on and locate this wherever appropriate. Now what you also get is the ability to determine dimensions that can be edited, and I really didn't go through that step as I created the library item, but at this point if I did wanted to come in here and click and change any of the dimensions, we do have the ability to go ahead and modify those on the fly. You can even make this a more excuse me, a more teed up process for your users by only having changeable dimensions available on this list. In any event, it creates the feature, and that becomes now part of the featured tree in that part. You can see when I hover over it that the through all holes maintained the through all behavior. You see them coming right out the bottom of this part. So build it the way that you want it to work. And in the end, if you do need to modify this uniquely from its design intent, you can always right click on the feature in the tree and essentially dissolve it, which is going to go ahead and break it up into several individual features. So those are the kind of things that we can go ahead and do in order to reuse data as readily as possible. Now these things can be very powerful. I have tools that I use to create what I call smart components, which are also drag and droppable library items. But to show you how these behave, what I'm simply going to do is grab a different folder here. And you see on my parts here, I have this really interesting area where we've got some holes that are built in. Now the holes are built in such a way that I can use parts off of my design library as well. And in the way that I've created this design library item, this clip, is I've actually created a mate reference in it. And what a mate reference is essentially a predefined mate that, since I'm not dragging the part by grabbing specific geometry and instead just grabbing it generically off of a library, this is the theoretical drag and drop point. Now what the behavior of that is when I drag it into an assembly and I hover over a hole, it automatically snaps that clip into place. So when I put it there, what I now have is a clip that I can finish up just by simply putting on the final concentric mate, and then that locates that component. But it's a really valuable and flexible tool. Now where I ramp this up with some incredible intelligence is something called a smart component. Now in this instance, this particular piece of geometry actually uses a clip that's a smart piece. Now that clip that you just saw actually has fasteners that hold it in place. It of course had a slot that I placed it in, and then it also has other parts it needs to mate to. Well, you can make clips that actually do that, not part of this demonstration, just want to show you the results. But it's a complete self-contained clip that as I drop it into place, I can go ahead and position it, which there are no places to mate to, as you can see. But once that part's been positioned, I can complete the process by clicking on it in the feature tree. You notice its icon has a lightning bolt. When you click the part, it exposes the smart feature in the graphics area. And when you click on that, it's going to ask you to complete the process by selecting one or a few different references. Now I didn't reference location, which would be left, right, up, and down, so it's not going to actually walk me through picking those faces. But what it does is I select the face that I want to place it in, and you'll see that it will automatically build a slot for this feature and place the fasteners. So with a little tab to hide here, you can see that I've actually got all the holes in place as well. So as I shift tab to unhide these parts, you'll notice that I can move this piece, and that's because I didn't put any location references on it. But as the clip moves, the whole for it moves with it because of the top-down relationship of this particular feature. So that's a fantastic way to use reusable items off of your drag and droppable design library. Now I'm going to do FeatureWorks in a little while as well. We'll come back to this design library and discuss a couple other aspects of it. Kind of cool things though. Now 3D Content Central is a library, as well as I'm going to jump through to McMaster-Carr, which are a couple of great places to go. So as a SolidWorks user, and frankly as anybody, because you don't have to pay for these sites, you can simply navigate with your web browser to these two locations. So I'm going to go ahead and just hit 3D Content Central, which is literally that, 3dcontentcentral.com. And when you go ahead and log into this, again, it's free. You just have to provide your email address. It's going to go ahead and give you a list of a bunch of different things, including people that have simply uploaded files recently, a bunch of generic parts and search mechanisms to find those, or you can just simply see all of the top-level suppliers. Now, you're going to want to check this out on your own. It is a blinding tree full of suppliers. So Destaco clamps, Destaco clamps, SMC linear actuators, Festo, Bimba, different bearing manufacturers. It's an incredibly huge list. So you're going to want to go ahead and check this one out. One I like is a company called Samtech, and they go ahead and make electrical connectors. When you're looking for these types of things, all you're really doing is selecting it as if you're going into these companies' libraries. So when you're looking at any of this information, you simply click on the folder itself or the company that we're looking at. The company that's near me is DME as well as Destaco. When you click on this, it says if you're going into their catalog. So you simply drill down by selecting, going deeper into each model type. And then when you get into the model type itself, you'll have access to the actual configuration of each of these models. So it's like you're picking it off of the catalog and grabbing a model number and even seeing a 3D graphical representation of the file. Now 3D Content Central is fabulous because it's not just SolidWorks file types that we allow for, and this is pretty astonishing, but pretty much any file type out there. Now typically these are featureless parts, but they would be in, say, Inventor's file type or Mechanical Desktop's file type or STEP AP214. So you can grab a specific CAD vendor if you'd like to grab those files and then use these documents directly in your assemblies. Some of these files come as SolidWorks native parts, featureless or featured, but with mates, and some are just simply built in their assembly position. Now for McMaster-Carr, that one's probably the poster child for awesomeness here. I'm just going to go to McMaster.com, and what you'll see on this one is their entire catalog. And what I find fascinating about this is as you start to drill down into the different files, so we're going to do a U-bolt with a mounting plate, you'll just grab a specific model type here, and if you grab product details in any of these locations, you'll see there's CAD files associated with those. What I love about McMaster-Carr is that it's one of the most amazing supplier sites that exists. And when you look at the download types, SolidWorks Native is the only native CAD file type that exists there. And I guess you could argue that DWG is also a native CAD type, but it's more generic 2D. When you download SolidWorks native files on this one, this is amazing. We'll go ahead and select that. It's going to open up down here in our downloads inside of Google Chrome. And when I actually open up this document in SolidWorks by simply clicking it, you'll notice it's actually a fully parameterized tree, including things like this helicoil sweep, which are your threads. Now, when you get a file like this that's generic, it's a big stress on your video card. And when you don't have features, you have to go through extra efforts to go ahead and scrub out things like these really high triangle graphic areas like helicoils. But with the SolidWorks parameterized part, you can come over here and simply suppress the threads, and now you've got a simplified representation of this McMaster-Carr part. So you will find very rich feature histories of all of the McMaster-Carr components in SolidWorks native format. So again, I find that fantastic. All right. So the next thing we're going to talk about here is FeatureWorks. Now FeatureWorks is a feature recognition tool in SolidWorks. Got a little slide out of order here, excuse me, that's not what we're looking for. With FeatureWorks, we get into the creation of our data. And when we're receiving files from other systems, those come in obviously a different way. They're a featureless folder in the feature tree, or a graphical body that's accurate in geometry, but doesn't have any sketch or featured dimensions to it. So let me pop out of this for 1 second, figure out why I have a couple of extra slides in here that I didn't deal with. And then we're just going to jump right into the feature recognition part of this. When you're in SolidWorks, and this is every license of SolidWorks, so feel free to experiment regardless of the level that you consume. When we open up non-native data, and I'm going to use just Windows Explorer drag and drop to expedite this, here I have some Parasolid files. And when you open up one of these types of files in SolidWorks, what you're going to get invariably is an imported solid, most likely, surfaces if it's bad geometry, but you get a featureless part. Now, what many people don't know is that with FeatureWorks, you can use it to quickly create features, not in an all or nothing scenario, but in a piecemeal type scenario. So if I wanted to edit this fillet right here, instead of trying to find a method to cut it away, I can right click on it and say Edit Feature. Now, if you pay attention to the feature manager, you'll notice that it'll actually build a fillet feature and gives me something that I can now edit through drag and drop or through dimensional modifications. So it's a real fantastic tool for quickly getting to a part that I now have something that not only can I modify, but I can simply suppress, and that removes it from the feature tree altogether. In the event that maybe I wanted to go ahead and define that with something different, maybe a chamfer, for example. So there's a lot of interesting flexibility while doing this. Now with this feature that I've recognized, I can really go anywhere I want with this. I can pick on a hole and say Edit Feature. What that'll do is give me now, in this case, a hole that matches my hole wizard, because of the size being a standard hole, so that's a great thing. It's editable now, so I can modify that. And then this chamfer up here, which is just an edge on a part so far, but if I hit Edit Feature, you'll notice the feature that gets created in the tree for this one. So this one actually put a chamfer up above the hole, just based on the way feature history works, and gave me now an editable feature that we can modify the angle and definitely modify the distance of that quite easily. So I love FeatureWorks for what it does for simple changes to pretty much any part that's out there. Where it can go the extra mile is with things like sheet metal parts. When I get parts from other systems, I can take this part and I can parameterize it with even sheet metal features by doing insert bends. But I also have a very nifty way of doing FeatureWorks. And when you want to do it on the entire part and just let the algorithm take care of it, you just right click the body in the tree and go to FeatureWorks and say Recognize. The neat and unique part of this one is that not only can I look at just standard features like extrudes and revolves and holes and fillets and things, but you can also go discretely to sheet metal type features. So if I wanted to find things like base flanges, sketch bends, yeah, maybe hems and edge flanges, we select a stationary face like we would when we're creating sheet metal features in SolidWorks natively, and then we just sit back and let the software take care of figuring out the rest. Now, as it goes through this, it's trying to defeature the part to make it more prismatic. And in an effort to do that, it gets rid of holes and fillets and chamfers first, and then it starts to get into the other types of features. So in this case, I have a series of sketch bends that it found. With this part, I'll simply say OK, and then we'll watch on screen how it builds the component. So it's done it now as a flat component. It put in all the holes here in the feature tree, and now it's individually bending each of these bends as sketch bends. I don't know if you're hearing what I'm hearing in my earphones, but I'm getting a lot of indications as it's creating the features. So what it's now done is taken this sheet metal part from any other system, and it's actually created a fully parameterized feature tree. And I can look at these features, I can walk through them step by step to see exactly what it looks like on the tree. So you can see we're bending up each of these flanges one at a time, and simply creating a part that now looks as though it was built in SolidWorks natively. So FeatureWorks is absolutely stunning for these types of operations, and it gives us the capability now to come in here and edit any of these features as necessary. Last, we're going to go ahead and hit PDM Standard. Now, I covered a bunch of this in a previously recorded webinar, which was our introduction to PDM Standard functionality. So a little bit of this is a retread, but for most of you out there, I think you're looking into what we can do and how it works. Whether you've had SolidWorks for a long time or not, PDM is one of those components that you may or may not have been using. So this is really relevant to almost everybody out there. What PDM Standard is it's data management. So when you think about usage, check in, check out, and revision control. When you check out a file, you take ownership, you take write access. When you check it in, you can release write access, which will then allow other people to edit the file. But it is permissions based, so you can control who can do those operations and frankly, who can see particular files at those stages in design, say pre-design to concept to in for approval to actually approved. You want different people to be able to see files at those different states. And that's where we get into revision control. You don't save over the file when you hit save, you actually create a new revision only at the time that you check it into the vault. And that gives you historical reference of how files have evolved from older designs that maybe get shipped to your customer to newer changes. Now it's secure access, which means people have to log in and those credentials control what they can see and do. And it's easy to simply add permissions or remove them from people, and really at a very granular level control who can do what in any folders within your company. So maybe relegate most of engineering only to engineers and nobody else could see it, but have some folders or files at a particular state visible to sales and management when it reaches the time where it's right for them to see those types of files, for example, after they've been released. What it also allows you to do is control templates. Because it's based on permissions, you can have folders of standards, purchase components, or even your start files, whether it's 2D drawing templates or 3D file templates. But having only limited ability for people to edit those means people can't accidentally save over your standard components, especially when it comes to templates that we're using to start files one after another. So it's great for, again, controlling permissions of who can do what to those very specific types of files. Finding and reusing is also a big part of this, because in Windows you can do searches, but I don't know about you, I find them painful. You have to do them over and over. They're not cached or indexed, so every one is a raw search. And when you've got a lot of hard drive space, doing a search for a particular file, it has to look through the entire hard drive and report back to you, and it's just not fun. So finding data in our vault is very quick. It's pre-indexed because it's a database that controls it, and it really allows you to do fast searches because it's only looking through text and tables. It's not doing a raw search every time you initiate a new search. You can also stop the duplication of files. When we have a lot of Windows data management practices, many times people will copy entire job or project folders and then tweak a few files within that folder, then ending up with new components that have evolved next to a bunch of copies of parts that never change. So we want to mitigate the amount of duplicates of the same file everywhere in your computer and lessen the burden that they cause. And then the last is that SQL Express is the database that controls this. Now it's SQL, which means it's a Microsoft database product, but this is what allows us to index things and have flexibility to change and move and rename files inside the vault, where when you do that in regular Windows, it can break references. Inside the vault, SQL controls those references, so changes made to file names and their locations will actually update the pointers from the other parts, assemblies, and drawings that rely on those files. So when you're inside of our vault, it's very free to move things. When you're in regular Windows, really bad things can happen when you start to manually rename and move files. So I even use this for my own purposes. Now this is a really old vault. I've been using this for 9 years now. So Darin's EPDM vault when it was called Enterprise PDM, but I trust it with all of the projects that I simply do at home, whether it's my treehouse project or my basement bathroom, or John Deere handle, or anything else that I create, and even my internal projects to DASI as well. So I really use it everywhere that I can. So let me just show you real quickly how this thing actually works for those of you who haven't seen it before. I'm going to go down into just raw Windows desktop right now for just a second. And I'm going to open up a Windows Explorer folder because essentially where we have this tool live is on your hard drive as what we call a vault view. So when I get into my C drive, what you're going to notice here is regular Windows folders, but then a series of them that have our PDM Blueberry on those. Now each of these are my local vault view. In the technical speak, the vault is on some server central to the company, but we don't work live across the network or live on files in the server. That's a performance problem as well as a corruption risk. So what we do is when people access the data, it actually copies local to their workspace. And when they make changes on it, they're actually making changes literally on, my case, the C drive. And when those changes are then saved, they're saved here on the C drive. And I can save all day long before checking those files back into the vault, at which time only the files that have changed go back into the server. So it's simply a copy out, copy in process as far as my server is concerned. Now when I get into my vault, I can click to access these. And sometimes if you're automatically logged in, some companies use this type of thing, sorry, and this one PDM standard doesn't support that, but when I get into my PDM standard folder, you'll notice it'll prompt me for login. Now in this case, I'm just going to log in as myself, but we take over your Windows folder in a very unique way by layering on other information about your files. Now when we're dealing with this tool for new data, it is literally a file save operation. So if I drop back into my SolidWorks sheet metal component, for example, and simply do a file save as, all I have to do is navigate to that folder. So I'm going to hit my C drive, I'm going to go down to my PDM standard folder, and then I take over the same look inside of my Save As box, as you just saw in Windows Explorer. Here I'll go ahead and simply save the file, and once I do that, it will simply add it to my vault location. In this case, I'm not editing it, and inside of SolidWorks, it'll then go ahead and populate the data card as necessary. And we'll add some properties as I save it. In SolidWorks, it'll let you know the status of the file. This particular file, who owns the document. So if somebody has the document, you're going to see just by hovering over their name. This means other users can't edit this file while I have ownership of the document. If we look back in our Windows Explorer Vault view, what you're going to see there is the file's been added, its version status and the description are also listed, and then again, who has that file checked out currently. So as a SolidWorks user, once I decide to close that document and release it from the SolidWorks interface, you'll notice all that information now checks in, the description populates, and we now have a document that we can simply release so that other users can now use. These wonderful comments here, they're a great habit to have. They will differentiate between one version of a file and another. So when we're looking at this file inside of our Vault view, we're going to see things like preview capabilities, the ability to measure on this document, which is even available for non-SolidWorks users when they're logged into the Vault. But you're also going to see things like the data card and how it's populated, version information if necessary. So all that information is stored. Now for existing data, which many of our customers obviously have, this is still just a Windows folder through and through. So when I right click and simply copy a folder into the Vault, that's how I can populate existing data. Now the data goes into the Vault initially in my local Vault view because I'm the person performing this operation. So a simple operation of grabbing the files and simply hitting check-in is now going to put these files in the central Vault and allow other valid or permission-based users to be able to do what their permissions allow with these documents. Again, previews are there based on our eDrawings professional tool. So as we select a component, we can see its file, we can see its drawing. And the real beauty of this type of information is that we also can see other things, especially as a SolidWorks user, that we wouldn't have access to otherwise, as a non-SolidWorks user, excuse me. That'd be things like the bill of materials, which shows us the structure and the quantity that we get calculated from the SolidWorks file itself. We also see what this assembly is comprised of and the location of all these files within the Vault. And then lastly, we see the where used. This is more critical because without data management, you can't see this. By selecting a part file, I can actually see where the part file is and where it's been consumed, so I know the trickle effect of any changes made to the part itself. Now I'm going to take these particular files here and simply check those out. And that's going to take ownership of the document, so now none of the other users in my company can actually work on those. And then we'll go ahead and simply open those in SolidWorks. Now when we open the documents up, we'll be able to see inside of SolidWorks who has permissions, again, what the structure of these files happens to be currently. So once they're all open, what I want to do is just pull open my side tab here, and you'll get an idea of whether we're looking at the part specifically or whether we toggle over to the assemblies or the drawings, what the layering structure happens to be between these files, and it recognizes the references between each of those as well. So we know exactly what's going on with respect to part and assembly structure and reference. Now, because we're talking about data management and control, we're talking about change management. And because of SolidWorks methodologies, let me get rid of a few of these other files just so that we don't have to confuse the issue. But when we're dealing with regular SolidWorks methodologies, what we're talking about in all instances here is the trickle effect of change. Now with SolidWorks, of course, we're fully associative. So when I go ahead and decide to make a change to a part file, for example, what will happen here is a few different things. That part file becomes dirty, which now shows here an indication of a pencil in my tree. And since I'm working on the file locally, I can decide to change it and the file's drawing itself just through simple update operations. Oops, excuse me, that's not what I meant to do. We're going to open up the drawing, and then you see associativity is going to show up on this as well. Now, with the change assimilated, I can hit save locally, and then that will save over the local cache versions, which now shows in my tree that my local versions are now newer than the last time these files were checked into the Vault. Now, I can change all day long and keep hitting save. The only time I actually create a new historical version is when I take these files and check them in. I'm not going to do that just yet. But if I toggle over to the assembly file, for example, take a look at it, it now shows the assembly being different because a part in the assembly has changed. And if we take a look at this assembly's drawing, we'll get the last step in the process, which is going to be the associativity through the whole change all the way down into the assembly level. So now here it indicates that the drawing and the assembly have changed, as well as a part file within it. So let's trigger this entire change. We'll go ahead and save the assembly top level at the drawing. It's going to update and again indicate that those files are now newer than the last time they were checked in. A simple check-in operation will now only push the changed files across the network. Files that haven't changed, files that are local, that are identical to the ones on the server, we don't need to stress our network out by copying files that are already on the network. All we did here was we updated the holes, and these innocuous little comments become powerful tools. Because now when I go ahead and check the feature history or the revision history of these files, which I'm now looking at the latest and greatest version based on my equal symbol, I can go back in time if my permissions allow, and I can see my comments listed indicating what version is what. Here in SolidWorks, I can actually go back to the previous version at any time I want to, and it'll backdate me to the original one of 2. What that will do on screen is it will also go back and get the versions of the parts and the other features that were those older versions the last time it was checked in. What it indicates in the tree is that those files are now older than the last time it was checked into the vault, which is one of those circumstances where it's neither good nor bad. It is simple historical fact. All this shows us now is what this assembly looked like when it was theoretically shipped at version 1. And we can go back in time to see what we need to modify if we need to retrofit or deal with a customer service issue. At any time, I can go ahead and take these files and simply get the latest versions of all of them, which will update everything that we have on the screen to version 2 of 2, and then that will simply show us what our assembly looks like today. Drawings update, parts update, everything updates on screen. Now the beauty of all this, and I'm going to cancel out of SolidWorks altogether, is that these same pieces of data are available now inside of the Windows Explorer Vault view. So a user that doesn't have SolidWorks would also have the same experience. You can look at the assembly, which clearly has the larger holes and the accidental transparent of the part. But at any point, I could go to this particular part and simply go back to its previous version, version 1 of 1. Here inside of my Vault view in Windows, we'll be able to see what that file looked like back when it was a previous version, and the similar indicators here indicating we're looking at older historical versions of some of the parts within this assembly. So that is some very basic PDM, but it is the central hub of what we're talking about there with revision control and check-in and check-out. Now, it really works the way you already work, only better. It's Windows, it's the same file structure you already have, it's even the same folder structure that you already have, but it layers the database on there and it makes it perform better by bringing the files local. Now, I want to expand on that just a little bit more, because what I really tout with this tool is what it does for network traffic. Is because it's a simple copy out operation, it's much quicker. When you open a file across the network, what it has to do is take that file off the server hard drive, it chops it up into data packets, and then it pushes it into the network card through whatever routers, switches, and hubs you have. This could be multiple steps. And then it pulls it into the local computer and reassembles all the data packets, which generally it can lose a few, so it takes time to reassemble. Then you work on the file, hit rebuild, and it has to chop them up, move them back to the server, and do all that work once again. That's a big process, and it's constant network traffic. So multiply that by the amount of SolidWorks users you have and how many people are in the same mapped network drive folders at the same time. When you use SolidWorks PDM, we basically get rid of these operations. It copies the files to your local hard drive, and from there it goes from RAM to hard drive to RAM to hard drive to RAM to hard drive. When you hit save, it saves it local. Only upon check-in will it then do the quick copy operation to the server. That's the extent of the network traffic. So it's a fantastic tool with that benefit beneath it, where it really does take care of a lot of the stresses that happen in a company where the server generally is an older computer that just has a lot of hard drive space. It's not that very good performing. We want you to get the most out of the local workstations that you're buying for your users, whether that's video cards, solid state hard drives, or the fact that they're just Dell towers with Xeons in them. We want you to use all that information and power. And when you're working off the server, you're not really working off that local space as effectively as you think you might be. So data management is a big help with those types of things. It also prevents accidental data overwrite, because even when I check it in as a new version, it has to bump the history. I'm not overwriting by simply hitting the save button like you would if you're just working in a regular Windows folder. And then lastly, it's SQL, it's SQL Express. So if you do decide that PDM Standard, which is included in your SolidWorks Professional and Premium licenses, isn't quite as elaborate as it needs to be with the maybe number of workflows that you have or the size of the data that you're going to be managing, there's always an easy upgrade path to the PDM Professional tool. So it's a very simple process by just doing that migration from Express up to full. So those are the topics that we covered today. Again, I encourage you to have fellow employees or anybody else that couldn't sit through this session at this time to watch this later. We'll have it up on our YouTube channel pretty quickly. But we covered the task scheduler and what you can do to automate operations that can happen at times where you're maybe not at your computer or off hours for compute purposes. We also talked about libraries and resources, whether those were of your own creation or simply using the ones that SolidWorks provides, or grabbing data from other resources where they're either supplier certified to be accurate, or it's just a giant repository of standard parts that you could spend time doing better things instead of modeling all these standard components. So McMaster-Carr is a great place for that. FeatureWorks will run feature recognition, so if you need to do modifications to files, even in a small amount, just simply isolate the feature recognition process and parameterize those things that you need to deal with. And then lastly, SolidWorks PDM Standard, which is included in all SolidWorks Professional and Premium licenses. Revision control, check-in, check-out, data management, and definitely stability and performance by not working live across the network, only amplified by a multi-user environment. You're working locally, and you're minimizing network traffic as a result of the mechanism that it is. So I want to thank everybody for spending 45 minutes with me today on a Wednesday. So we'll put this up on the website soon. If you have any other questions, please reach out to us through SolidWorks DASI Solutions Tech Support, which is simply tech support at dasi-solutions.com, or give us a call or contact your account manager. So thanks again, everybody, for taking the time to listen to a few things I had to show today. Have a great day. We'll see you again soon. Thanks.